Okay, so here is the shape that you were given, which has a hexagon, so all the sides are equal, and it has two congruent parallelograms. So the things that we can fill in are the fact that this angle here is 30 degrees, and we can also say that AB is X centimeters, it's a little wonky, and this is also X centimeters. We need to add some extra lines to this, which they haven't drawn in, but the lines that we're looking for are from point B to P, like this, and from point B to Q as well. One-handed is a little tricky for this. Ooh, slightly wonky. And then we've also got the line from P directly across to Q, like this. Okay, so they're asking us to solve this internal angle of this triangle here, PBQ. But we can't do that until we solve the triangle ABC, which we can do because we're given two sides and an angle, and we can use the cosine rule. So what we need to do is draw in a dotted line here. I'm doing it in a different colour so that you can see I'm working with a different triangle. And then I'm going to draw that triangle. Oh, I'm going to draw that triangle over here very badly, which is ABC. This angle is 30 degrees, and we know that this is X, and so is this, and this is the mystery side. Now the reason we want this side is because if you look at the diagram, the distance between A and C is equal to the distance between P and Q. So if we can find a formula in terms of X for the distance A to C, we can substitute that in to use PQ and find this internal angle here. Okay, we use the cosine rule for both of these, so there will be two steps of equations. So we will say that the length AC is equal to the length PQ. Now, your cosine rule is that A squared is equal to B squared plus C squared minus 2BC cos A of the angle. So in this case, A is our length AC, B is our length BA, which is X centimeters, and C is our length BC, which is also X centimeters, and A, our angle, is 30 degrees. So we have to substitute those things in. So AC squared is equal to X squared plus X squared minus 2 times X times X times cos 30 degrees. Okay, and then you've got to make sure that you're grouping all of your like terms together. So we get 2x squared minus 2x times x is an x squared. So we get 2x squared again there, and that's multiplied by cos 30, which we write like that. Now we can factorize this a little bit, and we can take the x squared term outside the bracket because it's in both terms. So we get x squared bracket 2 minus 2 cos 30. Now, if you look at the proof that they have given you, the proof states that the top of the equation is 2 minus square root 3. And what isn't very clear here is that this is 2 minus square root 3. So 2 of cos 30 is square root 3. So what I would literally do is write that in here as a little reminder for myself, because otherwise you're going to get a decimal and it doesn't get you the proof in the right format. So you can solve it, but you end up with a decimal value instead of the third that they're looking for. Okay, so what we get is x squared multiplied by 2 minus square root 3, like that. Okay, so now we have a formula for AC squared. We can go ahead and square root this formula to find AC, but we will be squaring it again when we use it in this PQ equation here. So I'm actually going to leave it exactly as it is, but I will write it underneath so that you have it, just in case. So AC is equal to the square root of x squared bracket 2 minus square root 3. So that's all in brackets there, so the square root sign applies to all of it. Okay, so remember that length AC is equal to length PQ. So we now have a formula for PQ, which means that we are finished with this ABC triangle and we can start focusing on this interior PBQ triangle here. So what I'm going to do is switch colour so that I don't confuse things. Oh, this is my attempt at drawing a diagram earlier that didn't go very well. So we've now got a triangle that looks a little bit more like this. We have our unknown angle at the top. P, B, Q are our points. And we have been told that BP is equal to BQ, which is equal to 10 centimetres. So I can put that straight into my diagram and say that this is 10 and so is this. And this length here is the square root of x squared multiplied by 2 minus square root 3. Okay, because that is the same length as AC. So now we need to play with the cosine rule again, so I'm just going to write it out to remind myself and make sure I'm putting things in the right place. So a squared is equal to b squared plus c squared minus 2bc cos a. But we have different values this time. So a is equal to length PQ, which we know is this formula that we solved in the first part. B is length BP, which is 10 centimetres, and C is B to Q, wonky writing there, and that's 10 centimetres as well. They're congruent triangles. And theta is the angle PBQ that we're trying to find. Okay. So we need to do a little bit of rearranging of the cosine rule because it's actually this bit here that we don't know. So we need to find that angle. So when we rearrange it, we get cosine A is equal to b squared plus c squared minus a squared all over 2bc. Okay. If you need some practice rearranging, we can look at the steps of how to go about rearranging that equation and others that might come up at a later date. Now we need to substitute everything in. So we've got to make sure we get everything in the right place. So cos A is what I'm trying to find, and we get 10 squared plus 10 squared minus, and then we take this here, but we're going to square it again. So that just literally means get rid of the square root sign at this point. So we get x squared bracket 2 minus square root 3. And that whole thing is divided by 2 times 10 times 10. Okay, so that's what we're up to so far. So that gives us 100 plus 100 minus x squared 2 minus square root 3, all divided by 10 times 10 is 100 times 2 is 200. So we get 200 minus x squared 2 minus square root 3 in brackets, all divided by 200. And we're getting pretty close to the end of the proof at this point. We're nearly there. If you have a denominator that is the same on the bottom, but you still have a subtraction or addition sum in the top, then you need to consider that each part is divided by that. So we could write this as 200 over 200 minus x squared 2 minus square root 3 brackets over 200. And what we get is 1 for 200 over 200 minus, and then if you look at the proof, the x squared is at the end, so I'm going to move it to the end of this now, and I get 2 minus square root 3 over 200 multiplied by the x squared. And if we look at the original formula, that is what we have to prove. So cos of A is equal to that, and cos of A actually means cos of the angle PBQ. Okay, so that's the proof for that question. There's quite a lot of work in it, and you have to be very familiar with the cosine rule and able to rearrange it, as well as using algebraic expressions and substituting one into another. So it is quite tricky, but hopefully that video will help, and let me know if you have any questions.